This is Unit 4, Lesson 3, Similar Triangle Problems. Before we get into the proportion work of this lesson, we're going to talk a little bit about naming figures. We're going to talk a little bit about the geometry we're getting into. We first need to understand the parts of a geometric figure. One part is the side. That's fairly obvious. Sides of each of these triangles. Okay. Another part is the vertex, and that's the point that's formed where two sides come together. And another part is the angle, and that is the angle that's formed where the two sides come together. Now when we go to name a figure, we're going to do that by listing all the vertices in order as they go around the figure. So in this triangle, we're going to name it first with the little triangle symbol and then A, B, C. Those are all three vertices. In this figure, it's a quadrilateral because it has four sides. So we're going to list it as quadrilateral, and then I'm going to start W, X, Y, Z, listing all four vertices as they go around the figure. However, it doesn't matter which one you start with, as long as you start with one and go in order either direction around the figure. So we could also call this quadrilateral X, W, Z, Y as another way of naming it. All right. We name the sides of a figure by listing the two endpoints with a line segment over the top. So you can see that these are the three sides of this triangle, AB, BC, and AC. However, it doesn't matter which order you list the two endpoints, so that we could list side AB as AB or BA, and those mean the same thing. Now we indicate the length of the sides of a figure by listing the endpoints only. So when we write it AB with no line over the top, we're actually referring to a value, a length of measure. So if we were going to list how long the side was, we would use the AB without the line over the top to indicate that. All right. Similar and congruent shapes. Two figures are congruent if they are the exact same size and the exact same shape. Here's some examples. You can see it doesn't matter whether they're lined up next to each other or turned around. As long as they're the same size and shape, they're congruent. That last one might not be as obvious, but you can see when we twist that around, it fits exactly on top of the other one. So they're the same size, same shape. Two figures are similar if they're the same exact shape, but they're different sizes. Here are some examples of similar figures. Same size, same shape, but you can see that they're different sizes. If figures are congruent, then we know a few things about them. We know that the corresponding angles, that means the angle from one figure that matches up with the angle of the other figure, are equal in measure. And we know the corresponding sides are equal in measure. So you can see in these two triangles, the little lines indicate that the angles of the red triangle are the same as the angles in the blue triangle, and the lengths of the sides in the red triangle are the same as in the blue triangle. You can see in this example, it might not be as easy to see, but you can see that there's a length of 18 feet of one side that matches up with a length of 18 feet of the other in the other figure. And you can see we've got 40-foot length in each side on each figure, and we have matching angle measures as well. In similar figures, the corresponding angles are equal in measure. You can see we've got 80 degrees, 65 degrees, 35 degrees in each of those triangles. The angle measures are all exactly the same. However, the corresponding sides are not the same, but they're proportional. So if we take the side lengths of the big triangle and the small triangle and put them in a ratio, simplified, that comes out to 2/1. Well, if we take another set of sides, big triangle over small triangle, 16/8, if we simplify that, you can see it comes out as the same exact ratio. And then our third ratio of sides also comes out to be exactly the same. Therefore, we can say that the sides are proportional because they all have the same ratio. Now, when we write that two figures are congruent, we write the name of the figure and we put this symbol in between. It looks like an equal sign with the squiggle over the top. Triangle ABC is congruent to triangle DEF. You can see that we have to line up the vertices in the way that we write the name so that the matching vertices with the same angle measure are in the same spot in our name. You can see that A and D are each listed first, and those are equal in measure, and B and E are equal in measure, and so those are both listed second, and C and F are also equal in measure, so those are listed third. Same thing with similar, but we write our notation without the equal sign. We just have the little squiggle. Triangle ABC is similar to triangle DEF. Now, we know that the length of the sides of similar figures are proportional, so we can write that as a proportion. If we take two corresponding sides, AB and DE, we can write those in a ratio. Since they're similar, we know that another set of proportional sides, say the pink ones, have the same ratios. We know that they're proportional, so we can write them in a proportion. And then that third set of sides, the green ones, are also going to be proportional, so we can write those as ratios that are all equal. We're going to use this to solve some problems. So, example 1, I want you to write the proportion just like we did in the last one, where the side measures are proportional. I want you to write that for these two triangles. Please pause the video and give that a try. All right, let's see how you did. Here we go. PQ over ST is equal to QR over TU is equal to RP over US. Now, it doesn't matter which order those ratios are written if you have them in a slightly different order. And remember, you can write PQ as QP, and it means the same thing. All right, so here's where we're really going to use that proportional relationship. We've got two triangles, but we've got some side lengths that we don't know. But we're able to use our proportional relationship to figure it out. So the first thing I need to do is identify we've got one set of side lengths that we know correspond, and we know both those values. So we're going to first write those in a ratio 4:6. Then we're going to look for another set where we have a missing value. We can write those in a proportion. Now make sure that you're putting the small triangle measures both in the numerator and the large triangle measures both in the denominator. We can solve that by cross multiplying, and we can figure out the missing length is going to be 8 inches. I'd like you to do the same thing to figure out the missing value of y. Pause the video and go ahead and solve for y. All right, let's see how you did. First thing I'm going to do is start with the ratio that I know, both sets of 4 inches over 6 inches. And now we're going to create a proportion with the two other measures, making sure to put the small triangle measure matching with the 4 on the numerator and the large triangle missing measure of y in the denominator with the 6. Cross multiplying, we came out with y equals 9.75. All right, example 3, we have the same situation, but it's going to be visually difficult for some people to figure out what parts are corresponding. So one way that you can do that is use color coding. And I look and see, hey, there's an angle that's got that one little arc indicated. So I know the other triangle has the same corresponding angle. So I put a dot, in this case pink, to show that those two are the corresponding angles. And then I find the angle with two little arcs, and I do a different color dot on those. And then I do a different color dot on the one with 3 little arcs. And so I can see then more easily which sides match up with which. So if I'm looking for the set of corresponding sides that I have in both triangles, you can see that between the blue dot and the yellow dot, I have corresponding sides that I have both measures, so I can put those in a ratio. Now, I'm looking for x, and I can see that x is between the pink and the yellow, so I know that that corresponds to the 20, because that's between the pink and the yellow and the other one. So I can set up that ratio, and then I know I've gotten them correct. and make sure small triangle are both in the numerator, big triangle are both in the denominator, or vice versa, as long as they match up. Now, I can see, don't forget that other method of solving a proportion. I can see that 10 multiplies by 2 very easily to get 20, so I can do the same thing in the numerator. 6 times 2 gives me 12. Therefore, I know that x equals 12, and I didn't need to cross multiply to find that answer. All right, I'd like you to pause the video and solve to find the length, missing length y. All right, so I'm going to start with that ratio that I know, 6 and 10, and then I'm going to set up a proportion with y and 5, making sure that the y goes in the denominator because that matches up with the big triangle. Now, we need to cross multiply. To find this one, y is equal to 25/3, and you can just leave it as a fraction in simplified form. All right, now in this figure below, we're told some information, and you can see side AB and DE, there's a symbol in between, and that symbol means is parallel to. So we know that the length, the side AB, is parallel to this other line DE. What that does actually is it forms a set of similar triangles. We've got our original big triangle, ABC, and that is going to be similar to the small triangle formed DEC. So for some people, it really helps to redraw it as two separate triangles. So we can write our big triangle, ABC, draw it and label it, and then draw the small triangle, DEC, separately, so it's easier to keep track of what's what. All right, now in example 5, we've got that very situation. So the first thing I'm going to do is redraw it as two separate triangles. So I've got my triangles here, and now I'm going to label them. You can see in the small triangle that tall side is 6, and the long diagonal side is 20. And so I'm going to label those just like I see them in the original figure. Now in the other one, you can see that the vertical side on the left is x, but now that long diagonal one, we have to find the unit of measure there by adding the 10 and the 20 together, so that's 30. So now this is a little easier to process because I can see my two triangles separately. So I'm going to do the small triangle over the big triangle as my ratio. Sometimes it's helpful to write that as a word ratio before I go ahead and do the rest. But we've got 20 for the long side and 30 for the long side of the two triangles. And now I know 6, but I don't know x, so I put that into a proportion, and I go ahead and cross multiply. Oops. And I go ahead and cross multiply. So now I go ahead and cross multiply, and I get that the value of x is equal to 9. That's it. Go ahead and put your note sheet in your binder. I will see you tomorrow.